Good night, sir.
Good night, Marika. How are you doing?
I'm all right.
You feel better today?
I feel the same.
Feel the same. Understand. All right. I really hope that you get better very soon. And tomorrow is Sunday. You can just sleep in and get lots of rest tomorrow. All right.
Yes, sir. Thank you.
So today we're starting differentiation. All right. And before we can start differentiation on the unit 2 syllabus, we have to look at differentiation from unit 1. All right, so we're going to look at the basics of differentiation. All right, so that's what we're looking at right now. All right, so you remember anything from module 3 last year, calculus? What is differentiation?
Not
Really?
not really, since it was rushed at
Yeah.
the end for us, so I don't really remember anything.
All right, so we're going to talk about differentiation today. So what is differentiation? Differentiation, it's a process. What kind of process? Is a process in order for us to find a gradient. We're able to find the gradient at a point on a curve in any particular time. All right, so the gradient of a curve varies from point to point. And the reason why the gradient changes from point to point is because a curve, it changes direction. So let me put on something graphically for you to see what this is saying. So this is a curve, right? This is a curve. Let's say this is a curve. At each different point, the slope is different, don't it? The slope is different. How you find gradient of slopes? So from what you do in maybe physics from third form or fourth form was this. So let's say you're given a slope. You'd have given lots of slope in physics, and they would ask you to find the gradient in labs, right? So for C-Sec physics, lots of labs, and they ask to find the gradient. And to find the gradient, what you do is plot the graph. So let's say you're plotting maybe voltage versus current, right? You're plotting V and I against each other, right? And let's say it looks something like this. As the voltage decreases, the current increases, and so they say it's inversely proportional, right?
Yes, sir.
Now, if we wanted to find let's say we wanted to find the gradient between this particular point, between, let's say this is an I value of A, and between an I value here of B, how do we find the gradient? How do we find the gradient between here to here? You did physics in C-Sec, right?
No, sir. I didn't do physics.
Oh, you didn't do physics. Oh, which science
Or
subject did you
is it?
do?
Um, I I didn't do a science subject.
Oh,
I
okay.
just I just did HSB, which I don't think they count that.
Okay, I understand. For some reason, I thought you did physics. I don't know why.
Is
Maybe because you
I
did
do
go.
remember something up. Is it like when they have the thing called rise over run?
Yes, rise over run.
y2
Yeah.
minus y1 over
Yes.
x2 minus x1.
Yes, that's what I wanted to hear. Yep. So what they do in physics is they tell you to pretty much create a triangle and find rise over run. How much did it rise between this span? And so let's say this have a y value of y2 and this have a y value of y1. And what they'd say is the gradient between A and B, what they'd say is the gradient between A and B is rise, which is y2 minus y1. That gives you the rise over the run. And the run is x2 minus x1, which in this case would be b minus a. Now that would give you the gradient. That would give you the gradient between here. All right. But what I want to point out is this curve. If we were to, let's say you were to find the gradient between here and this point. So you want to find the gradient between here and here. It's going to be different. The slope will be different from finding the gradient here. And if you were to find the gradient between here and here, the slope will also be different than if you were to find the gradient between here and here, don't it? Can you see that the slope will be different?
Yes, sir.
All right, and the slope is different because the gradient of a curve varies from point to point. Now, instead of doing this all day, finding, drawing some secant line and talking about rise over run, differentiation is a process that will allow us to find the gradient of a line or the gradient of a curve at any particular point in time. That's what differentiation is. It's a process that allows us to find the gradient at any particular point in time. All right, that's differentiation. So let's go back to C-Sec math. In C-Sec math, you would have learned about how to find the gradient of the line, right? So when they give you the line y equal mx plus c, what does the m stand for?
The gradient.
M stands for gradient. Very good. Y equal mx plus c. What does the c stand for?
Center.
Repeat.
Center.
The c stands for the y-axis intercept. So when you get a line, all right, the gradient of the line is m. So the gradient meaning the rise over the run. Gradient is this, rise over run. That is gradient. Gradient is slope. Always remember, gradient is slope. Gradient is slope. Gradient is slope. So the rise over the run is the gradient m. C is the y-axis intercept. C is the y-axis intercept. That tells us where the graph cuts the y-axis. All right. All right. Now this is the equation of a straight line. Now differentiation allows us to also show that the gradient of a straight line will just be m. All right, so the gradient of a straight line, as we know, is m in a straight line y equal mx plus c. But for a curve, it's a little bit different. For a straight line, the gradient is constant everywhere, don't it?
Yes, sir.
Gradient is constant everywhere for a straight line, all right? Because it's traveling in a smooth path. But for a curve, it's different. It's a little bit different for a curve because a curve, it can be going up, and then all of a sudden you stop here, so then you go down, then you stop and rest for a little bit, then you probably start walk again, then you slow down. And so the gradient is going to be different for a curve. All right, that's how one curve probably look. Another curve probably looks something like this, which has different gradient as well. And so the gradient of a curve varies from point to point. And so differentiation will just be the process that allows us to find the gradient at different points. All right. All right. So now that's a gradient. Differentiation is a process that allows us to find the general expression for the gradient of a curve. This expression is called the gradient function and is used to find the gradient at any point on the curve. Now, if the equation of the curve is y, then the gradient of the function is dy by dx. All right, so anytime you see dy by dx, that is just the gradient function for the curve. All right, so if y equal a function of x, so y equal f of x, then the gradient is dy by dx, which is f prime of x. That means the rate of change of y with respect to x. The gradient of a curve at a point is equal to the gradient of the tangent to the curve at that point. So let's say that again. The gradient of a curve at a point is equal to the tangent to the curve at that point. So what that means is, this is what we mean. Let's say you have a curve. Let's say you have a curve. Let's say this is a curve. All right. Now, if you want to find, let's say you want to find the gradient at this point. The gradient at this point, an easy way to find the gradient of this point is by finding the gradient of the tangent at that point. So this is a key information to remember. The gradient of a curve at a point is equal to the gradient of the tangent of that point. So the gradient at this point, this line would be the gradient at this point. All right, so if we're finding the gradient at this point, this blue dot, it would be equal to the gradient of the tangent at this point. Now, what is a tangent? What's a tangent?
A tangent is a curve of
Yeah, what's a tangent to a curve? Tangent line to a curve.
the formula.
No, not no formula. Just define what's a tangent line.
The tangent line touches the curve at a point.
All right, good. That is a tangent. A tangent line is a line that touches the curve at only one point. All right, that's a tangent line. So a tangent line to a curve is any line that touches the curve at only one point. So it only intersects the curve at one point. So what we would say is that this line is a tangent to the curve, and that point right there is known as the point of tangency. It only touches the curve at that one single point. All right, so this line is a tangent to the curve. All right. And again, the gradient of the curve at this point is equal to the gradient of the tangent at this point. All right. All right, cool. Very important to remember this. I will say it one more time. The gradient of a curve at a point is equal to the gradient of the tangent at that point. All right. That's how we find the gradient at a point. And the gradient at a point is given by dy by dx. That's the gradient function. All right, the gradient function is dy by dx. All right. And here it is, the gradient of a curve at a point is equal to the gradient of the tangent to the curve at that point. All right. All right. So now what we need to look at now is a general rule. Imagine, ignore all of this with the limit and delta. This is the proof. You don't need to know the proof, but I like to put proof just in case somebody wants to know how did they derive the formula. All right, so this is just a proof of y is the differential of x squared 2x. All right, so I was proving the formula before we get to it. All right, so this is the general rule of differentiating functions. Now we're going to start with differentiating y equal ax to the n. All right, so if y is equal to ax to the n, the general rule of differentiation is you bring down the power. So you bring down the power n, then it's multiplied by a, and you subtract 1 from the power, so it becomes x to the n minus 1. That's the general rule. So if y is equal to ax to the n, to differentiate it to get dy by dx, you carry down the power, then you subtract 1 from the power. Carry down the power, then you subtract 1 from the power. All right? That's the general rule of differentiation. So, for example, y equals c. If y is equal to c, that's just a constant. Y equals c is just a constant. A constant is really c times x to the 0, don't it? This is a constant, don't it? C times x to the 0. What is x to the 0?
X.
X to the 0, what's anything to the 0 power? Anything to the 0 power is 1. So y is equal to cx to the 0 is still y equal c. And so if you were to differentiate it, you're going to see that dy by dx is equal to, you bring down the power 0. And that's why the differential of a constant is 0. Because when you carry down the power, you get 0 times cx times cx. To that, you subtract 1 from the power to get minus 1. But 0 times anything is 0. And so when you differentiate a constant, you get 0. Now look at this one now. X. When you're differentiating x, if y is equal to x, x is really x to the 1, don't it? Right?
Yes, sir.
So when you differentiate it now, when you differentiate y, you get dy by dx. So when you write down dy by dx, what you're going to get is you carry down the power 1, you subtract 1 from the power to get x, carry down the power 1, subtract 1 from the power to get 1 minus 1. But 1 minus 1 is what? Are you there?
Yes, sir.
All right, so y is equal to x to the 1. You carry down the power 1, subtract 1 from the power, but then 1 minus 1 is 0, x to the 0 is 1. So this just works out to be 1. So that's why the derivative of y equal x is 1. When you differentiate kx, this is really k times x to the 1. So you carry down the power to get k, subtract 1 from the power, you get x to the 0, and so that's just k. Now this one is incorrect, and I put this one there purposefully so we can fix it. What it should be the derivative of 4x cubed?
So it would be 4 times 3.
Very good. 4
So
times 3, which
12.
is, yeah,
So 12x to
12x
the squared.
squared. Beautiful. 12x squared. Lovely. Is this one correct?
Yes, sir.
Yes, it's right. Very good. Now, is this one correct?
Yes, sir.
Nice, because we bring down the power first. Nice. Is this one correct?
Yes, sir.
Very good. Nice. So again, this is the general rule. If y is equal to ax to the n, then dy by dx is equal to nax to the n minus 1. All right. That's the general rule. Now, we're going to look at sums and differences. Sums and differences mean now, of course, when you're getting a function, you're not going to just get a function 5x cubed to differentiate or 4x cubed. You're going to get a one bag of term, don't it?
Yes, sir.
Nice. So now we're going to learn how to differentiate functions like these now. So we call them sums and differences. When you're differentiating a function like y equal x to the 4, 2x cubed plus 4x squared minus 5x plus 7, you differentiate them term by term. So first you differentiate x to the 4. What's the derivative of x to the 4?
4x cubed.
Very good. So that's how we get this 4x cubed right here. Then what's the derivative of 2x cubed?
Negative 6x squared.
Very good. Negative 6x squared. That's how we get that. What's the derivative of 4x squared?
8x.
Lovely. The derivative of minus 5x?
Negative 5.
All right. And the derivative of a constant is?
Sir, why is it negative?
Why is it negative 5?
It wouldn't be negative 5x.
When you differentiate negative 5x, what you're supposed to get? Think about it. So you have negative 5x. What's negative 5x? Negative 5x to the 1, don't it?
Yes,
Right?
sir.
Then how you differentiate this now?
Negative 5x to the 1. That's negative 5.
Negative 5x, and then you carry down the power. Then what you do next? Subtract 1 from the power.
So it'd be 0.
So you get 1 minus 1, which is 0. But then what's x to the 0?
Be 0.
X to the 0 is what?
It'd be x.
X to the 0 is what?
Oh, sorry, it'd be 1.
Anything to the 0 power is 1. And so we just get negative 5. All right? So that's how we get that the derivative of negative 5x is negative 5. Cool?
Yes, sir.
That's how we differentiate sums and differences. We're not even going to look at composite yet. I'm going to give you some examples to differentiate. Let's say I give you this. Y is equal to 5x squared minus 10x plus 6. How do I differentiate this?
So it would be 10x
All right, so tell me what I start with first. I need to say
dx over dy.
dy by dx, not dx over dy, dy over dx. So dy by dx. So remember, we're differentiating y in terms of x. That's what this means. So if this letter was, let's say, v, then it would be dy by dv. All right? So we're differentiating in terms of x. So dy by dx is
10x
10x, yeah,
minus 10 plus
minus
0.
10 plus 0. Very good. All right, good. Let me ask you this now. Let me tell you that x is equal to 3t cubed. X is equal to 3t cubed minus 6t plus 6. How do I differentiate this?
dy.
dy, where is the y from?
Oh, dx.
dx.
dx over dt.
Very good. dx over dt, yeah.
Is equal to 9t squared.
9t squared. Yes, that's true. 9t squared, yeah.
Minus 6 plus
9t
0.
squared minus 6 plus 0. Very good. No need to put the plus 0. Very good, Marika. Excellent. And that's how we differentiate sums and differences. Lovely. Let me give you one more just to practice makes permanent, so no problem with one more. So let me say y is equal to 5 minus v cubed minus 3v squared plus 2v. How do I differentiate this?
dy over dv
Very good. dy by dv
is equal to 0
yeah,
minus 2.
oh, this is a 3.
So 3,
Yeah,
3v squared
yeah,
minus 6v
minus 6v
plus 2.
plus 2. Beautiful. Excellent, Marika. Excellent. Wonderful. Very good. All right. And so that's dy by dv. All right. Now, next thing that we're going to look at now is what's known as the composite rule, or some people call it chain rule. The first composite rule we're going to look at is, let's say y is equal to fg of x. What do I mean by that? It means that we have a function inside another function. All right, that's what composite function means from CSEC days. You have a function inside a function. Now, how do you differentiate a function like this? It means you differentiate f first. If you have a function fg of x, it's f prime of g of x times g prime of x. All right, that's how you differentiate a function inside a function. So here's an example. For example, you have y is 5, 3x squared minus 7 to the 4th power. All right. So composite rule is you differentiate this function first. The inner function is 3x squared minus 7. So to differentiate this, you carry down the power. 5 times 4 is 20. You subtract 1 from the power. 4 minus 1 is 3. But then you differentiate what's 3x squared. So you differentiate inside the bracket. You differentiate, so you get times, differentiate what's inside the bracket, it becomes times 6x minus 0. And so this is dy by dx. So if we were to finish write this out now, we could finish and write by saying dy by dx. The final answer would be 20 times 6x is 120x. This is the final answer, 120x times 3x squared minus 7 all cubed. All right. And that's that. You understand this? Understand composite rule 1? Let's try example. So let's say I gave you that y is equal to, let's say I say y is equal to 7 into 3x minus, let's say y is equal to 3x minus 6x squared square. What's dy by dx? What would be dy by dx? So y is equal to 7 times 3x minus 6x squared all square.
So, how you get 20? Sorry.
Oh, I get the 20 right here.
Mm-hmm.
So first thing you do is bring down the power. So it becomes the 4 times the 5. And the 4 times the 5 is 20. Then you subtract 1 from the power, and that's how we get the 3. Then we multiply it by, differentiate what's inside the bracket. When you differentiate 3x squared, we get 6x. When we differentiate negative 7, we get 0. So just multiply it by 6x.
Okay, I understand. Wait.
So how do you differentiate this one?
Okay. So it would be 7 times 2, 14.
All right, very good. So 7 times 2, that gives us 14. Yes.
And then brackets.
Brackets.
3x
Yeah.
minus 6x squared.
Yeah, 3x minus 6x squared. Yes.
Yeah, that's it.
And finish?
I think so.
And I finish it. Then you're going to multiply it by the differential inside the bracket. We haven't differentiated the term in here yet.
Okay. So that would be 3.
So multiply it by bracket 3.
And then
multiply it by 3
-12.
minus negative 12x. Very good. Now notice I put a bracket around 3 minus 12x, but I did not put a bracket around 6x. Tell me why I didn't put a bracket.
Because 7 is 0.
Very good. So I didn't need to bracket it and say 6x minus 0. All right, but because of this bracket now, when I differentiated these two terms, We're going to get 3 minus 12x. I have to put a bracket around it to show that it is 3 minus 12x being multiplied by all of this. I'm going to give you some more examples on another sheet. We're going to do about 3 more examples just to make sure you fully master composite rule type 1. So let's see, y is equal to, let's say y is equal to 5 times x plus 1. Y is equal to 5 times x plus 1 cube. Let's say y is equal to 1/3. Y is equal to 1/3. 1 minus 2x. 1 minus 2x cube. All of this is raised to the 4th power. And finally, let's say y is equal to 6 times 3x minus 5x squared to the 5th power. You have 3 different types. Call this question 1, question 2, question 3. So talk to me, Marika. How do we differentiate number 1?
dy
So for number 1, we're going to have dy by dx is
equal to 15
yeah,
x
15
plus 1 all
x
square
plus 1, x plus 1 all square, yeah,
times
times
x.
times x
No, it would be 0.
times 0. If you multiply everything by 0, it would just be 0.
Mm-hmm.
No, it's going to be, what's the when you differentiate x, what you get?
1.
Times 1. Very good. So it's times 1. When you differentiate 1, we get? When you differentiate 1, what we get? So this answer finished now?
Yes, sir. Wait.
Yes.
Yes.
And we can just write it as this, 15 times x plus 1 all square. We don't need to have the times 1 because when you multiply it by 1, it doesn't trouble anything. So let's leave it at that. All right, now question 2. How differentiate question 2?
Dy over dx is equal to
Equal
4/3.
4/3, yeah.
1 minus 2x cubed
Minus 2x cubed, yeah.
Cube.
Cubed, very good. Yeah.
Times 0 minus 6x squared.
Very good. Times, put a bracket, 0 minus 6x squared. Wonderful. Now, if you want, you can simplify it by saying negative 6x squared times 4 over 3. That's going to be 4 times 6 is 24. 24 over 3 is negative 8. So you get negative 8x squared times 1 minus 2x cubed. You see all that, the negative 8x squared? Did you see I get this?
You times the 4 over 3.
Times this, yeah. So the 4 over 3 times this. 4 over 3 times this is 0. Then you get minus 4 over 3 times 6x squared. That's 4 times 6 is 24. So you get negative 24, and it's being divided by 3. 24 over 3 is 8. All right?
Yes, sir.
So that's how you simplify it. You always want to simplify it afterwards. Let's look at number 3 now. What's dy by dx?
30 bracket 3x minus 5x squared to the fourth pole times 3
30 bracket 3x minus 5x squared. Yeah.
times 3.
So raised to how much power?
Oh, 4
Raised
to the
to the
fourth
4,
pole
yeah.
times 3
times bracket 3
minus
minus
10. Yeah, 10,
10.
negative 10x.
Very good. Negative 10x. Good. Very, very, very good. Nice. And that's known as chain rule.
So once you have it down to that, so we're looking at the third one. Do you have to break it down further?
Yes.
So 30 times 3.
Yes. And 30 times 3 is what? 30 times
20.
3. That gives us 30. Yeah. Minus 30 times 10.
300.
300. So you get 30 minus 300x. Put a bracket. And all of this is then multiplied by 3x minus 5x squared to the fourth whole.
Isn't it 90, sir? 90
That's 90.
minus. Hmm?
Oh, 30 times 3, yeah, that's 90. Sorry.
Yes.
Yeah. 30 times 3 is 90 minus 300x. Good. Times 3x minus 5x squared. And all of this is raised to the fourth power. Good. Excellent. All right. Now, let me see now. Now there's type 2 in differentiation. All right. Type 2. And the second type of composite now is when you have y written as a function of t and t written as a function of x, how are you going to find dy by dx? To find dy by dx, this is what you use, what's known as, connected rates of change. So if y is written as a function of t and t is written as a function of x, you use what's known as connected rates of change to get dy by dx. So here, dy by dx is going to be dy by dt times dt dx. Because if you were to cancel the dt's, because in reality you're multiplying them, though the dt's would cancel each other, don't it?
Yes, sir.
So this
So then
makes
you
sense.
just have the dy times dx.
Very good. dy by dx. So this makes sense, don't it?
Yes, sir. That's
All
the
right.
proof?
No, this is just a formula.
Okay.
Yeah, so dy by dx is dy by dt times dt dx. All right, so let's look at this example. Y is equal to ft to the 4th power. So what's dy by dt? What's dy by dt? Y is equal to 5t to the 4th power. What's dy by dt?
20t cubed.
20t cubed, good. 20t cubed. Now look at this now, t is equal to 3x squared. So what is dt by dx? What's dt dx? Differentiate t with respect to x. What's dt dx?
6x
6x, good.
minus, yeah, it just be 6.
6x minus 0, which is just 6x. So now we can find dy by dx now. And in this case, dy by dx is going to be equal to dy by dt, which is 20t cubed, 20t cubed. But then what is t? T is 3x squared, don't it? Minus 7.
Yes, sir.
So dy by dx is then 20 t cubed, replace t with 3x squared minus 7 all cubed, times dt dx. dt dx now, this is t, 3x squared minus 7, and so dt dx would be just 6x. So multiply it by the 6x. Now look what I'm going to show you now. I'm going to show you something, why this formula is accurate. Now let's say from the get-go we substituted t as 3x squared minus 7. So we're going to rewrite y strictly in terms of x. So to rewrite y strictly in terms of x, we could have said that y is equal to 5 times t to the 4. But what is t? T is 3x squared minus 7 to the 4th power, don't it? So this would be y, don't it? All I did was replace t with 3x squared minus 7. Agreed?
Yes, sir.
Nice. So now that I rewrite y strictly in terms of x, what would be dy by dx?
Twenty
20, yeah.
20t cubed.
20 what?
So would it be 23x squared minus 7?
All right, so look at this. Let's look at this. We'll have 5 times 3x squared minus 7 to the 4. How would you differentiate this right here?
It would be 4 times 520, 3x squared minus 7 to the third power.
Yeah, exactly. So it's just 20 times 3x squared minus 7 to the third power times
Times
what?
6x.
Times 6x. Good. Now look at what's above. Notice that when you differentiate this, when you differentiated this using composite rule 2, and when you use composite, and when you just connected them, notice that you get the same thing. So you see that this formula is right. All right, you're gonna learn soon in module 2, we're looking at parametric equation. They call this parametric equation, and T is known as a parameter. All right, and we can connect them using what's known as parametric differentiation, but we'll look at this later on when we reach parametric equation in module 2 for unit 1. All right.
Yes, sir.
All right, good. Now, I want to give you some examples of type 2, but not yet. Not yet. Now we're going to learn about products and quotients. How to differentiate products and quotients. Now when you're given y is equal to 2x plus 1 times 3x squared, you can't just look at it and differentiate it yet, don't it? You have to expand it first, no? Don't it?
Yes, sir.
So expand it, we get 2x times 3x is 6x cubed, 2x times minus 5x is negative 10x squared, 2x times 4, that's 8x, 1 times 3x squared is 3x squared, 1 times minus 5x is minus 5x, 1 times 4 is 4. So what we get is 6x cubed, then minus 10x squared plus 3x squared is minus 7x squared, then 8x minus 5x is 3x plus 4, then that would be y. Y is 6x cubed minus 7x squared plus 3x plus 4. So now to find dy by dx, we differentiate 6x cubed. Differentiating 6x cubed, we get 18x squared minus 14x plus 3. Now what I'm saying to you is there's an easier way than expanding all of this. There's what is known as product rule. When you have the product of two functions, there's a rule in order to differentiate it, and this is the rule. If y is equal to the product of two functions, they call it u times v. So u is a function of x times v. So if you have y is equal to u times v, then dy by dx is going to be equal to v du plus u dv. This is dy by dx. dy by dx is equal to v, meaning this function v, times du, which is the differential of u, means you differentiate u, plus u times the derivative of v. All right? v du plus u dv. I might use different letters in this note, but they're virtually the same thing. In the same way now, so this is going to be product rule. So don't worry, I'm going to come back to this function soon. We're going to differentiate this using product rule. Now let's look at the second one now. The second one is a quotient. In order to differentiate this function, there are two ways we can do it. The first way would be all of this is divided by 3t. And so we can separate them as individual fractions by saying 9t squared over 3t, that's 3t. Then minus 2t over 3t, that's just minus 2 over 3. Then put plus 5 over 3t. You see how I separate this? So I divided each term by 3t. You good with that?
So each term is divided by 3t.
Yeah.
How did you? Okay, yeah. Okay.
That's good.
Yes, sir.
All right. Now dividing each term by t, I get 3t minus 2 over 3 plus 5 over 3t to the minus 1. Agree with that? All I did was rewrite the 5 over 3t as 5 over 3 times t to the minus 1.
Yes, sir.
All right, you have to rewrite it as t to the minus 1 so you can differentiate. So now to differentiate it, I differentiate it term by term. The derivative of 3t is 3. The derivative of a constant is 0. The derivative of 5 over 3t to the minus 1 is, I bring down the power, so it becomes minus 5 over 3. Then I subtract 1 from the power to get minus 2. And that's equal to 3 minus 5 over 3t all squared. Because this t to the minus 2 can go in the denominator as t squared. So it becomes minus 5 over 3t squared. Cool. Now look at this now. This is finding the gradient. This is finding the derivative of products and quotients that are expandable. Now what I'm going to do now is use this formula that y is equal to u times v and that dy by dx is v du plus u dv. So we're given this. All right, so we're given this and we're going to use, what we're going to use now is we're going to use the product rule. So I'm going to copy this question and we're going to use product rule. Remember, we got an 18x squared minus 14x plus 3. We're going to use the product rule now. Just because I'm lazy to write, I'm typing. Insert equation. This is what we had. Y is equal to 2x times 3x squared. Yeah, this was y. And we wanted to find dy by dx. Now, what the product rule tells us, this is product rule. Product rule tells us if y is equal to the product of two functions, u times v, then dy by dx is equal to v du plus u dv. That's the product rule. If y is equal to two functions u times v, then dy by dx is equal to v du plus u dv. So in this case, in the question above, what we're going to do is we're going to let u equal to, what's u in this case? 2x plus 1, because we're going to write it as the product of u times v. So we're going to call u 2x plus 1, and we're going to call v, what are we going to call v?
3x squared minus 5x plus 4.
3x squared minus 5x plus 4, good. That's what we're going to call v, good.
Sir,
Now,
are you using another screen?
oh, you're not seeing it? Oh.
I mean, I'm looking at the one where you have the example and you put
Okay,
y
I
is
see what
equal to.
happened. I see what happened. I was right here. My apologies. All right. So we were just writing down the product rule that tells us if y is equal to u times v, Then dy by dx is v du plus u dv. That's dy by dx. So if y is equal to u times v, then dy by dx is v du plus u dv. All right? That's dy by dx. Now, after we write down dy by dx is v du plus u dv, now what we can do now is use product rule to find dy by dx. So using product rule, dy by dx is equal to v du. V in this case is going to be 3x squared minus 5x plus 4 times du. What's going to be du? So using this formula, what's du?
Oh, wait, sir. I'm going to get my charger.
All right.
Um, 2x plus 1.
All right, now 2x plus 1 is u. What is du? Du means you differentiate u. Du means differentiate u. When you differentiate u, what would you get? When you differentiate
2 plus,
you get
it's just 2.
you get 2, yeah. So now look, this formula now right here we have our v du, but now we need our plus u dv, plus u dv. Now plus u is 2x plus 1, u is 2x plus 1, and then our dv, what's dv?
Um, 3 to 6x
6x
minus 5.
minus 5, good, nice.
So you have to put what v is, then differentiate u, then
Yes,
plus put what
plus
u is,
u
then
differentiate
differentiate
v.
v.
Very good. All right, and that's dy by dx. That's product rule. All right, this is known as product rule. All right, this is known as product rule. So now let's do that now. So now multiply the 2 times 3. What we're getting is dy by dx is equal to 6x squared, right? 2 times the 3x squared, 6x squared, minus 10x. Tell it with me what we get, plus what? Plus, I'm just expanding the brackets now. Plus 8, plus?
Oh, you're times in. Okay.
Yeah, I'm multiplying out now.
Plus 12x squared
12x squared, yeah.
plus 10x
Plus 10x or minus 10x?
minus 10x
Minus 10x, yeah.
plus 6x
Plus 6x.
minus 5.
Minus 5, very good. Now look now, all we're going to do now is group them, simplify them. So dy by dx is the 6x squared plus the 12x squared is 18x squared, don't it?
Yes, sir.
And then the minus 10x plus 6x is what? Minus 10x right here. Then a
Negative
minus,
14.
you get negative 14x, good. Then you have 8 minus 5. What you get? 8 minus 5?
3.
Plus 3. Good. So look, this is dy by dx. for this function. Now look at this now. We got dy by dx plus 18x squared minus 14x plus 3. This was when we expand it and differentiate. Now when we use product rule, we'll get the same thing. You see that?
Yes, sir.
Nice. We get the same thing because this is an easier method. Now you might look at it and tell me, but sir, wouldn't it be
What
easier
do you
to
mean same
expand?
thing, sir?
Repeat.
What do you mean same thing?
I say it's the same thing, meaning if you use this as dy by dx, or you were to expand them and then differentiate, you're going to get the same answer.
Okay.
All right. Now you might ask me, but sir, why would you want to use product rule? Because expanding it and differentiating it look easier, don't it?
Yes, sir.
Now, what about a case where you're going to be asked to differentiate, let's say 2x plus 1 to the 4 times 3x squared minus 5x plus 4 to the 7th. Now, when something is raised to the 4th power, that's hard to expand, don't it?
Yes, sir.
And when some raised to the 7th, that's even worse. So those are the times when product rule are going to be very important. So you're going to need to know product rule for when we're doing those sorts of questions. All right, so product rule comes in very handy when we're expanding brackets with very high powers. So that's when we really use product rule. All right. Now let's look at the second example using the quotient rule. So let's use the quotient rule now. All right, let's look at quotient rule. So now what quotient rule tells us is, this is quotient rule now. If y is equal to, I like to call it t over b, meaning if y is equal to top over bottom, then dy by dx is equal to, this might sound funny, but this is how I used to remember it. You start with the bottom. You start with the bottom times the differential of the top minus the top times the differential of the bottom over the bottom square. All right, so that's what I use to remember this formula, quotient rule. You start with the bottom and you end with the bottom square. So you start with the bottom times the differential of the top minus the top times the differential of the bottom over the bottom square. So that's the formula to use quotient rule. All right, so let's go to the example that we had around here. So we're going to get the same exact answer, 3 minus 5 over 3t squared. We're going to get the same answer using quotient rule now. So let's copy this. It told us z is equal to this. Told us z is equal to 9t squared minus 2t, and all of this is being divided by 3t. So that's z. Z is 9t squared minus 2t plus 5. over 3t. All right, that's C. So this is Z. So Z is 90 squared minus 2t plus 5. All of that is divided by 3t.
Oh, so it's
Now,
showing the other page.
okay, why do I keep doing that? So I just rewrote over Z right here now. All right, so now we're going to use quotient rule. Quotient rule is you start with the top, you start with the bottom times the differential of the top minus the top times the differential of the bottom over the bottom square. So you're going to have to study those rules different. Product rule, quotient rule, composite rule. So much to study, but we can do it. So now, to find dz by dt, what you're going to have to do is you're going to write down, in this case, you're going to write down your top. The top part of this is, what's the top part? What's t?
The top?
Yeah, let me call it a different t for this case. What's capital T?
90 squared
Yeah, 90 squared.
minus 2t plus 5.
Very good. Plus 2t, 5. Very good. And what is the bottom now? What's b?
3t.
3t. Very good. So now what we're trying to find is, we're trying to find dz by dt. Now dz by dt is equal to, you start with the bottom. So the bottom is 3t times the differential of the top. What's the differential of the top?
18
18.
t
Yeah.
minus 2
Minus 2. Yeah.
and then the
Minus the top. Put a
90
bracket
squared
now. 90 squared.
minus 2t plus 5
Yeah.
times 3t squared.
The bottom, which is times the differential of the bottom. And what's the differential of the bottom?
60.
The differential of 3t is 60.
Yes.
When you differentiate 3t, you get 60. How you differentiate
But
3t?
it's supposed to be, okay. It just be 3.
Just 3. Very good. Then it's all over the bottom square divided by the bottom square. What's the bottom square?
3t squared.
Not 3t square, it's 3
Six.
square t square, which is 9t square. All right?
So
3t square means 3t times 3t, all right? That's how you square something, all right?
okay,
3t
so
square is 3t times 3t, all right? So what
yes,
if I'm
sir.
asking you for, what is the square of 4x cubed? What would be the square of
16x to the 9th power.
to the 6th power? 16x to the 6th power. All right. 16x to the 6th power. Let me write it down somewhere here so you can see. So let's say you're squaring 4x cubed. 4x cubed all square. 4x cubed all square means you're multiplying 4x cubed times 4x cubed. That means times 4x cubed, don't it?
Oh, you have to add the two cubes.
Very good, yes. By laws of indices, we add the powers. So it becomes x cubed plus cube, and you get 16x to the 6. All right. So these things are very important when you're squaring. All right. A lot of people make the mistake and say 4x cubed all square. They just write, oh, they just square the number. You have to square this term too. Both of the terms are being squared. Right? So that's very important to note. So this is dz by dt. All right. All right, now what we're gonna do is simplify it now. So all we're gonna do is simplify the numerator and simplify the denominator. All right, you might look at it and say again, sir, isn't quotient rule longer? No, quotient rule, it looks longer, but what about cases when you'd get something like maybe 9t squared minus 2t plus 5 all raised to the 13th power divided by 1 minus 7t. And that would be difficult to expand and divide, don't it? And so in that case, it would be better to use quotient rule. So that's why they came up with quotient rule, to be an easier way so that we don't have to be trying to expand all the time, because expanding can take forever. So let's simplify it. 3t times 8, tell me what we should get. 3t times 18t is? Yeah, so expand for me, Marika. 3t times 18t?
54t squared.
54t squared. All right, yeah.
6t.
Minus 6t. Yes, yes.
And then 27 minus 27t squared.
Minus 27t squared. Yeah.
Minus. Yeah.
It's going to be plus now, because minus and minus give plus.
Oh, I was doing it from the other side.
Okay, but still it will work out to be plus now. So you're going to say now, plus what?
60.
Plus 60, yeah.
Plus 15.
Minus 50.
Minus 50.
Yeah, and that's divided by 90 squared. Good, now we're almost finished. All we have to do now is simplify. So we're gonna group our t to the t squared. And so what we get is 54 t squared minus 27t squared. That's just what, 27t squared, right?
Yes, sir.
So let's get 27t squared over 9t squared. And we're gonna get, we'll group our t's. When we group our t's together, what we get?
It cancel out.
They cancel? Nice, so we just get 0. Then group our constant. What we get when we group our constant?
15.
So that's have
-15.
minus 15 over 9t squared. Good. So this gives us dz by dt. All right, that's dz by dt. Now after we get dz by dt now we just need to simplify this. 27 over 9 is 27 over 9?
That's 3.
That's 3, and t squared over t squared cancel each other, right?
Yes, sir.
Good, and then minus, what's 15 over 9?
5 over 3 t squared.
5 over 3 t squared, so 5 over 3, and t squared in the denominator, so 5 over 3 t squared. So 3 minus 5 over 3 t squared. Now look. That's what we got. 3 minus 5 over 3 t squared. That's when we were expanding it. Now product rule and quotient rule will come in very handy when you're unable to expand. So again, you just need to remember these two formulas. Quotient product rule is if y is equal to u times v, then dy by dx is v du plus u dv. It's known as product rule. And then quotient rule is if y is equal to a fraction with a top over bottom, then dy by dx is start with the bottom times differentiate the top minus the top times differentiate bottom over the bottom square. That's quotient rule. All right. Cool?
Yes, sir.
Good. All right. Now let's see what we're going to look at now. All right, now we're looking at tangents and normals, the curves. I was wondering to come back to this, but I think this is perfectly fine. Now, oftentimes, you're going to find questions, they're going to ask you, they're going to say, Marika, given a curve is defined by this, find the equation of the tangent at a point. Now, remember what we said earlier about tangent? What was the first thing we said about tangents earlier? What was the first thing? All right, the first thing we said about tangents was that the gradient of the, we said that the gradient of the tangent, at a point, the gradient of the curve.
The y2 minus.
We said that the gradient of the curve is equal to the gradient of the tangent at that point. All right, and so that's how you find the gradient of a tangent. The gradient of the tangent is equal to the gradient of the curve at that particular point. So the tangent at a point P touches the curve at P and has a gradient MT known as the gradient of the curve at that point. So to find the gradient of the tangent, you find dy by dx when x is equal to whatever the x value at P is. Then they're going to ask you to find the equation of the tangent. The equation of the tangent is given by y minus yp, and it's equal to the gradient of the tangent into x minus xp. So you're going to have to remember this formula. This formula is what we use to find equations of tangents. All right, this is the formula to find the equation of the tangent, where mt is just dy by dx. All right, mt is dy by dx, gradient of the tangent. Now, the tangent and the normal are perpendicular to each other. The normal at a point P is perpendicular to the tangent. So what that means is Since the normal is perpendicular to the tangent, then the gradient of the normal is -1 over the gradient of the tangent. And so the equation of the normal is given by y minus yp, and is equal to the gradient of the normal into x minus xp. So here's an example now. It says find the equation of the tangent and the normal to the curve y equal 2x squared minus 5x plus 7 at the point where x is equal to 2. We're going to do this together, and I'm going to give you an example to do. Because I can't bother to write, I'm going to go to Word. All right, so it says find the equation of the tangent and the normal to the curve Find the equation of the tangent and the normal to the curve y equal to 2x squared minus 5x plus 7 at the point where x is equal to 2. So we need to find the equation of the tangent and the normal. Anytime they give you a curve and they're asking you for equations of tangent and normal, the first thing I want you to do is write down this, dy by dx, all right? What would be dy by dx?
The it would be 4x
4x
minus 5.
minus 5, very good. 4x minus 5, that's dy by dx. Now that you find dy by dx, then next thing you're going to need to do is plug in x equal 2. So at x equal 2, what we're getting is that the gradient of the tangent, we're going to call it mt, at t equal to, we're going to say the gradient of the tangent mt is equal to dy by dx when x equal 2. It's equal to dy by dx when x is 2. So what we're going to do, we're going to plug 2 into this equation. So we get 4 times 2 minus 5. This is now known as the gradient of the tangent. So 4 times 2 is 8. 8 minus 5 is 3. Now, after you find the gradient of the tangent, the equation of the normal is given by y minus yp, y minus yp, y minus yp, and it's equal to the gradient of the tangent times x minus xp. Now my question to you, Marika, is what are we going to substitute now for xp and yp to get the equation of this tangent here? What's xp and what's yp? What's xp and yp?
Would y be 4x minus 5?
Go again.
Could y be 4x minus 5?
Y would be 4x minus 5. All right, now when they say yp and xp, these are, so look, we have xp right here. They say at the point, p stands for point. P means point that is given. So the point that is given is, the point is, if you're to write it down as a coordinate, the point that is given, P, is 2, but they don't give us the y value. How do we find the y value for this point?
The y value would be 3.
3, how you get 3? How you get the 3? 3 is the
Because,
gradient. To get the y value, look, this is what the question tells us y equal, don't it?
so the y value is 4x minus 5.
No, look what I'm showing you. Look what I highlight right there. Y equal this, don't it? Look at this portion that I put it in, let me put it in color red. Do you see what I put in red? You see what I put in red?
Yes, sir.
And so when x equal 2, all you need to do to find y is say, when x equal 2, y is equal to 2 times x is now 2. So you put 2 times 2 squared minus 5 times 2 plus 7, don't it? That not give you y. That give you y now, don't it?
Yes, sir.
Nice, so this gives us y. So 2 squared is 4, 4 times 2 is 8. So we get 8 minus 5 times 2 is 10. And then we'll add 7, right? And so 8 minus 10 plus 7. And so 8 minus 10, that is negative 2. Negative 2 plus 7, that is 5. You get the same thing that I get. You get 5. Y is 5.
Yes, sir.
And so the point is 2, 5. The point is 2, 5. So we're finding the equation of the tangent at 2, 5. So what we do now is say, okay, this is the equation of the tangent. So the equation of the tangent is going to be y minus yp. Yp is 5. So we're just going to write y minus 5, and it's equal to the gradient of the tangent, 3 into x minus xp, and xp is 2. So that's the equation of the tangent. Of course, they're going to want you to simplify it. They always want you to simplify, meaning make y the subject. So don't leave it like that. So what you're going to do is say, well, that is implying we can bring over the 5 to say y is equal to 3x minus 6 plus 5. Tell me if you agree with that. See what I get 3x minus 6 plus 5?
Yes, sir.
Nice. And so that is telling us then that the equation of the tangent is y equal to 3x minus 1. So that's the tangent.
So to get the gradient, you have to differentiate
Yes. To get
and
the
then you plug in,
gradient, yeah. Then you plug
then you
in the
plug in
x value
x,
that they give you. Yeah.
and then to find y, you plug in the x value into the original equation.
Yes, yes, beautiful. That gives you y. And then to find the equation of the tangent, you use this formula. So let me write it right here. This is the equation of the tangent. Now the question not done yet. They ask us to also find the equation of the normal. So this is the equation of the tangent. The equation of the normal is given by y minus yp. Equation of the normal is given by y minus yp equal the gradient of the normal into x minus xp. And this gives us the equation of the normal. Now, how do we find now? How do we find the gradient of the normal? That mn right here. How do we find mn? Now, because the tangent and the normal are perpendicular, then the gradient of the normal is -1 over the gradient of the tangent. All right, mn is -1 over mt. So that's how we find the gradient of the normal. So the gradient of the normal in this case is -1 divided by the gradient of the tangent, which is 3, don't it? So the gradient of the normal is -1 over 3. So now that we find the gradient of the normal, we can find the equation of the tangent by using this formula and replacing mn with -1 over 3. So we're getting that the equation of the normal is, replace this with -1 over 3, and then yp as we know it, yp in this case is now, p was 5 and xp was 2. So this is now the equation of the normal. All right, and then all you do is make y the subject. I can't bother to make y the subject, so I'll stop it here. This is the equation of the normal. All right. All right.
Yes, sir. So you always have to make y the subject.
Yeah, you're supposed to make y the subject. Because you want to write it in the form y equal mx plus c. All right, that's the tangent, y equal mx plus c. All right, so I'm going to give you an example to do now. Find the equation of the tangent and normal to the curve. I'm going to give you a different curve. I'm going to call this curve x cube minus 3x squared. You're going to work this out for me now. Minus 3x squared plus 2. So y is equal to x cubed minus 3x squared plus 2. And I want you to find the equation of the tangent and the normal when x equal, let me see. When x equal 5. So all years, Marika. Tell me how we do this now. So we're gonna write example 2. So this is yours.
I don't remember all the formulas
Go again.
for it. I don't remember all the formulas for it.
So here are the formula. Equation of tangent, this is the formula. Equation of the normal, this is the formula. And then you now know how to find the gradient of the tangent by finding dy by dx.
Okay, so to differentiate it, it'd be 2x all squared minus
So differentiating,
6.
go again, we differentiate x cubed, what you get?
2x squared
You get 3x squared, yeah?
3 to 6 6x
Plus 6x or minus 6x?
minus 6x.
Minus 6x. Good. So that's dy by dx. What do you do next?
And you plug in the x values of 5.
Very good. So at x equal 5, when you plug in x equal 5, what you're really finding is the gradient of the tangent. So you can say at x equal 5, mt, you don't have to call it mt, I like to call it mt. At x equal 5, mt is equal to dy by dx when x is 5. So mt is equal to dy by dx, and this is when x is 5. So that's the gradient of the tangent when x is 5. So as you rightfully said, you plug in 5 to get 3 times 5 squared minus 6 times 5. What is that?
So that'd be 15 squared minus 30. So
15 squared. 5 squared is what? 25. 25 times 3 is 75. What's the final answer you're getting?
225.
Where you get 25?
225. 225.
You're getting 325?
225.
5 squared? So look at this now. 5 squared is 25. 25 times 3 is 75. So I'm getting 75.
So it's not 5, there's 15. 15 squared.
No, you squared.
Oh,
It is
so
3 times
75.
5 squared. It's 75 minus 30. And that's 45. So get this is 45. Nice. So get the gradient of the tangent. So what's the equation of the tangent now?
You have to plug back. You have to plug in 5 into the original equation first.
Very good. To get the y point. Very good. So let's plug in 5 now. So we're getting y equal to 5 cubed minus 3 times 5 squared plus 2. So what's y?
$125
125. Yeah.
minus 75 plus 2.
Minus 75 plus 2. What's that?
52.
Very good. 52. Nice. So now what's the equation of the tangent?
I don't remember how it's written.
So here's the formula. It's y minus yp. Just to copy it, this is equation of the tangent. All the coordinate geometry, I'll prove to you why that's the equation of the tangent. This is the equation of the tangent. So talk to me now. I'll plug in actual values. What's the equation of the tangent?
Y minus 52
Yeah.
is equal to 45 x minus 5.
Good. So that's indeed the equation of the tangent. Good. That's the equation of the tangent. So if you want, you can simplify it. You can go further and simplify it to get that y is equal to, bring over the minus 52 to get 45x minus 5 times 45 is, let's see, 5 times 45, what's 5 times 45?
225.
How much?
225.
225, so that's 225, and then, so we're getting 225 plus 52. What's minus 225 plus 52? That looks like minus 173. So that's why. Y is 45x minus 173. Good. Now what's the equation of the normal?
1 over the gradient.
All right, so before you can find the equation of the normal, you need mn. You need mn, but once you know mt, you know mn. What's mn? What's the gradient of the normal?
45.
Gradient of the normal is minus 1 over the gradient of the tangent. So what's the gradient of the normal?
1 over 45.
Negative 1 over 45. All right, negative 1 over 45. All right, so that's the gradient of the normal. So then what's the equation of the normal? That's the equation of the normal.
I don't remember the formula for that
It's
one.
the same formula as this one. It's just
Oh,
that the gradient changed.
okay. So it's y minus 52 is equal to negative 1 over 45
Negative
minus
1 over,
5.
very good. Negative 1 over 45 times x minus 5. Good. And that's the equation of the normal. All right, good. This is the equation of the normal. Wonderful. If you want, you can expand and make y the subject, but I can't bother with that now. So we'll leave it at that. And all you do is bring over the 52 and expand that bracket. Good. All right, so here in this question, we did it. We did it around here. Remember, we got 4x minus 5, we got 3. At x equal 2, we got that. We got our y value. We got the gradient of the tangent. Then we get the gradient of the normal. Then we get the equation of the tangent was this, y minus 5 equal gradient of the tangent times this. We worked out all of that and got these. Nice. Now, next thing we're going to talk about now is increasing or decreasing functions or stationary points. All right. Now, increasing functions. I'm going to sketch a graph to show you what we mean. So, remember we said that when we differentiate a function, we get the gradient, don't it? Don't it?
What did you say, sir?
When we differentiate a function, when we differentiate y, we get the gradient, dy by dx, don't it?
Yes, sir.
Dy by dx give us gradient. Now, whenever the gradient is positive, when dy by dx is positive, we say that the function is increasing. All right, because the gradient is increasing. It has a positive slope. Now, when the gradient f prime of x is another way of writing dy by dx, all right? So get used to seeing this too. F prime of x is the same as dy by dx, all right?
Yes, sir.
All right, now when f prime of x is less than 0, we say that the function is decreasing. And when f prime of x is equal to 0, we say that the function is stationary. So I'm going to show you now a graph first. So look at this now. All right, let's say I give you this now. Let's say you have this line, right? You have this line, you have this line, and you have this line. Tell me what's the gradient for this line. What do you know about this line in terms of its gradient? When
The
a line,
line going at the whole line or the broken line?
yeah, think of, just ignore these two lines. So ignore this one for now.
That it goes through X.
All right, ignore the graph. So just ignore the graph for now. Let me remove the graph. Let's say you have this line. What do you know? If you see a line like that, what do you know about this line? What do you know about this line in terms of its gradient? What do you know about this line?
Sure.
All right, let me ask you a question then. If I were to give you the line y equal to 3x plus 2, how would you sketch that line? How do you draw that line? Y equal 3x plus 2. Let me remove this. How do you sketch a line y equal 3x plus 2? If you had a graph, right, how would you draw the line y equal 3x plus 2? How do you sketch this line, Marika?
Would be the y-axis.
What about the y-axis?
2. So the point would be 2.
It passed through 2 and it have a positive gradient of 3, don't it?
Yes.
How do you sketch a line with a positive gradient?
So it would have
So this is how
and
we sketch a line with a positive gradient. All right, so it have a positive gradient and passes through 2. All right, that's all we're saying. So when a line has a positive gradient, it goes this way, all right? This means it's rising more than it's running. Rise over run give us gradient. And so this graph has a positive gradient. So why did I bring this up? Just to make a conclusion. Anytime you see the shape of a graph looks something like this, let's say a line looks something like this, you know that the line has positive gradient. All right, a line that looks like that has positive gradient. Now, what if they give you a horizontal line? What's the gradient of a horizontal line? So what we're saying right here is that the line has a positive gradient, and so dy by dx is greater than 0. The gradient is positive. Now when they give
So
you a
if it's
horizontal line,
horizontal,
yeah,
it's
if it's horizontal,
is it greater than 0?
if you get a
It
horizontal
should be
line,
greater.
how do you find the gradient of a horizontal line? How do you find the gradient of a horizontal line? So I'm going to give you a horizontal line and you tell me what its gradient. Horizontal line are y values. So let's say I give you a horizontal line. Let's say I give you the line y equals 2. This is the line y equals 2. All
So it
right.
doesn't have an x value.
All right. Now let's say this is when x is 1 and let's say when x is 3. And I ask you for the gradient of this horizontal line between these 2 points. What's the gradient between 1 and 3? What would be the gradient? Oh,
So would it be 2?
go again. How find gradient?
Would you plug in y equal mx plus c?
All right, no, that's not how find gradient. That is, you're telling me the gradient for the equation of a straight line. We find gradient by, let's say we have the 2 points. We find the gradient between 2 points. The gradient between 2 points is rise over run. So what would be this point right here?
So it'd be like 1, 2,
Yeah, so that's the point 1, 2. What's this point right here?
3, 2.
3, 2. So how do we find the gradient between these 2 points?
Um,
Y2.
y2 minus y1.
All right, y2, which is 2 minus y1, 2 over
3 minus 1.
3 minus 1. But what is 2 minus 2 over 3 minus 1?
0 over
0.
2.
0 over 2, which is 0, don't it?
0.
0 over anything is 0. So what's the gradient of any horizontal line?
0.
0. All right, why is it 0? Even without calculating it, tell me why the gradient of any horizontal line is 0.
It doesn't pass through the x-axis.
No, because it doesn't rise. Remember, gradient is
Oh, since
rise
it's flat.
over run. It's never rising,
Okay.
it just flat, don't it?
It's
So the rise is 0, and so 0 over anything is 0. It doesn't matter how far it want to run, but if it never rise, then the gradient is going to be 0. So dy by dx equals 0 for any horizontal line. So dy by dx equals 0 for any horizontal line. All right. So when it has that slope over there, when it's going from left of your screen to right, positive gradient. When it's a horizontal line, gradient equals 0. Now what if the slope is going like this, going down? What's the gradient when it looks like that?
with the gradient be
Negative.
negative?
Because it's not rising, it's declining, don't it? This a decline, don't? You can
Yes,
just
yes.
put one rock and it just roll down the rock because it's declining. So if it's not rising, then it can't be positive because gradient is rise over run. Decline would be opposite. So in this case, we say that dy by dx is less than 0. So remember these three cases, This is when the gradient is decreasing. This is when the gradient is decreasing. This is when the gradient is stationary. This is when the gradient is increasing. So remember these 3 bits of information. It's absolutely critical you remember them. All right, absolutely critical. Now, next thing we're going to talk about is what's known as stationary points. All right. So what is stationary point? What the word stationary mean? If I tell you that,
Doesn't
Marie,
move.
yes, not moving. So when you're not moving, what happened to the gradient? What happened to the
And
gradient when you're not moving?
it stays the same.
The gradient is 0, not stays the same. It's if you're not moving, then you're not rising. You're not going to any distance, don't it? So you're not rising, and so the gradient is 0. So the gradient at stationary point means dy by dx equal 0. You got that? You got that?
Yes, yes.
So the gradient at a stationary point, dy by dx equals 0. So let me show you some typical questions they'll ask you. They'll ask you now that given that y is equal to this, they ask you find the stationary points. All right, but then we know that at a stationary point, dy by dx equal 0. So I'm going to give right down 2 examples, and we're going to do these 2 together. All right, so this is stationary points. And what did we say happen at a stationary point? What happens at a stationary
0.
point? dy by dx is 0. The gradient is 0 because we are not moving. All right, at a stationary point, dy by dx is 0. So this is a typical example of what they like to ask now. So let's say, given that the equation of the curve is given by let's say y is equal to x cubed. Let's use the same example we had up there. Y is equal to 2x squared minus 5x plus 3. Let's say given that the equation of the curve is that. Now my question to you is find the stationary point or points. Find the stationary points. Find the
Sorry,
stationary point.
can you switch to the other screen?
And my apologies. I don't know why I keep doing that. All right, so given that the equation of the curve is y equal 2x squared minus 5x plus 3, find the stationary points. So how are we going to find the stationary point or points? How do you think we do this question?
You differentiate the equation.
Very good. So let's differentiate it. So dy by dx equal
4x minus 5.
yeah, then what would do next?
Then it'd be d squared y over d squared x.
What? What's it going to be next?
I'm not sure.
All right, now when you find dy by dx, what do you know about a stationary point? At a stationary point, dy by dx equals 0. So
So we
set this
equate it to
equals
0.
0. Yeah, so equate it to 0 because that's what happened at a stationary point. Then
So
we solve for
4x is
x.
equal to 5.
The x equal?
4x is equal to 5.
And so x equal 5 over 4, right?
Okay.
X equal 5 over 4?
Yes, yes.
Nice. So now we'll get x. No, this is just a coordinate. So what is going to be the point? So this is just the x coordinate. We need to find the stationary point. How do we find the stationary point?
Would you plug 4 over 5 to the original
Yes, say it with
equation?
confidence, man. To find y, you need to plug x back into the original formula because that's y. So we're going to plug in 5 over 4 square minus 5x plus 3. So we'll do that. Yeah, do that now, man. We'll do that. We'll get 5 over 4 squared is 25 over 16. Oh, plug the x right here as 5 over 4 as well. All right, so plug x as 5 over 4 as well. And so we just simplify that now. Put that in the calculator and tell me what you get. What you get when you put that in the calculator?
So the first one is 25 over 8
It's work out to be 25 over 8, yeah.
and negative 25 over 4.
Yeah, plus 3. So add those now and tell me what you get.
Negative 1 over 8.
Negative 1 over 8. All right, so that's y. So what's the stationary point? So as a coordinate, it's 5 over 4, comma, negative 1 over 8. All right, so this is the stationary point. All right, that's the stationary point. All right, so 5 over 4, negative 1 over 8, that's the stationary point. That's the point at which the gradient is equal to 0. All right?
So, sir, what's the real world value for this?
Repeat.
Like, where would you use this sort of problem?
I'm not hearing you. Go again.
I was saying that where would you use this sort of problem?
In module
Like,
3. In
no,
module
like
3?
in real life.
Okay, in terms of a real life situation,
Yes.
we use differentiation in, I want to use an example that's relatable to computing. I can give you some general ideas. We use differentiation, for example, when we're investigating water waves. So persons that work in those sort of industry, they use water waves and they're going to have to come up with differential equations and formulas to find out stuff about waves, shallow waves, all of those stuff. So I did that in a course called differential equations. All right, so you use differentiation mainly in that. But in terms of computing, an area of differentiation, let me see where computing use differentiation and application. The only area I can think of where computing use it is connected rates of change. Connected rates of change with this question, for example, let's say in terms of coding, maybe you have to do you have to write a program in terms of a variable in Pascal program, and then maybe you have to write it in another pseudocode algorithm that's different from Pascal, where you have to convert from one variable to another. And this is where connected rates of change differentiation will come into place. All right, so that's the only practical definition I see with computing. But this is mainly for my field now, more than mathematics. Differentiation in terms of calculus, you mostly use calculus in mathematics areas, all right, in real life,
Okay.
all right. In terms of computing, you mainly use what you learn in module 1. Module 1 is mostly where computing use math. In terms of binary, in terms of reasoning and logics, those sort of stuff you use a lot in computing, because reasoning and logics, P implies Q, and if P then Q. You do that in computing when you're doing your if-then statements and stuff like that, when you're writing an algorithm, don't it?
Yes,
You
sir.
need to know binary when you're doing binary in computing, because binary generally work with zeros and ones. So module 1 in unit 1 really deals with computing. Those maths, you're gonna do those a lot, but differentiation as per se is more for specific math suited persons that are going in maths field. All right, you just need to know it for general knowledge, but it's not gonna be so much in computing. All right.
Yes, sir.
All right, so this would be the stationary point. I'm going to give you another example to try. All right. So this only have one stationary point. It can have more than one stationary point. So now I'm going to give you an example with more than one stationary point. So let's say I ask you this now. Given that the curve is y equal to x cubed minus 6x squared plus 6. Now I ask you to find the stationary points. 3x cubed minus 6x squared plus 6. And I ask you to find the stationary points. How do you find the stationary points?
Um, dy over x equal to 9 squared minus 12x.
You were breaking up. Go again. dy by dx is?
9x squared minus 12x.
Yeah. Now who's going to find the stationary points?
It's 0.
Equals 0, because at a stationary point, dy by dx is 0. Good. What do we do next? So you solve that equation, 9x squared minus 12x equals 0.
So 9x squared is equal to 12x.
You don't need to do that. To solve this equation, you can factor out 3x, because 3x is the highest common factor, so you get 3x times 3x minus 4, don't it?
Yes, sir.
That's equal to 0. So if 3x times 3x, both of them, if the product of those equals 0, then either 3x equals 0 or 3x minus 4 equals 0, don't it?
Yes, sir.
And so x equals 0 or x equal 4 over 3. All right. Now, what are we going to do next now? Because that's just a coordinate. How are we going to find y?
Plug 43 back into the original equation.
All right, so plug in 0 first. When you plug in 0, you're going to get y is 6. Or you plug in 4 over 3 now, you're going to get y is, what you get when you plug in y as 4 over 3? We're getting 3 times 4 over 3 cube minus 6 times 4 over 3 square plus 6, and I'm getting 22 over 9. All right, so the two stationary points are, so the stationary points are 0, 6 and 22 over 9. 4 over 3, 4 over 3, that's the x coordinate, and the y coordinate is 22 over 9. All right, so that's the stationary points. Cool?
Yes, sir.
Good. Those are the stationary points. All right, now that we have that, no. Now that we have that, that's how we find stationary points. Now, next thing we're going to look at, don't worry, we'll soon close, soon finish. We're going to do differentiation in 2 parts. All right, what we're going to look at now is the second derivative. No, yes, there's a second derivative. You can go further and notice that when you get dy by dx, you get another function in x. Now, when you find the second derivative tells us the nature of the stationary points. So notice when we get 2 stationary points a while ago, it tells us whether it's a maximum stationary point or whether it's a minimum stationary point. So if the second derivative is negative, then it's a maximum stationary point. Let me say that again. If the second derivative is maximum, then if the second derivative is negative, then it's a maximum stationary point. And if the second derivative is greater than 0, then it's a minimum stationary point. All right, so here's an example. Find the stationary points, y equal 4x cubed plus 3x squared minus 6x minus 1, and determine the nature of each stationary point. So to find dy by dx, we would get 12x squared plus 6x minus 6, don't it? That would be dy by dx, 12x squared plus 6x minus 6. You agree with that?
Yes, sir.
Now you can go ahead and differentiate this again. When we differentiate this again, we get d2y by dx squared, meaning we differentiate it again the second time, so we'll call it d2y by dx squared. That's 24x plus 6. Now at the stationary point, dy by dx is 0. So solve 12x squared plus 6x minus 6 equals 0. Solving this equation, I use the quadratic formula to get x equal -1 and x equal to a half. Now, after I get x equal 1 and x equal to a half, I plug in x equal -1 back into the formula to get y. And so the point I get is -1, 4. And then when I have a half, I plug in back x as a half to get y. And I get a half and another a half and -2.75. Now I have two stationary points. One of them is going to be minimum and one of them is going to be maximum. To find out which one is maximum, at a maximum stationary point, d2y by dx squared is negative. So d2y by dx squared is 24x plus 6. So I'm going to plug in x being -1. When I plug in x being -1, I get -24 plus 6, which is less than 0. And so -1, 4 is a maximum stationary point. Now when d2y by dx squared is positive, like when I plug in a half, then it is a minimum stationary point. All right, that's known as the nature of stationary points. All right, so that's cool.
Yes, sir.
So let's go back to this example now. I'm going to ask you for these two questions that we had to determine the nature of these stationary points. So let's go down back. The stationary point we found for the first example all right, and let's just add on and determine their nature. Determine their nature. Determine their nature. All right, so we have dy by dx is 9x squared. So we have dy by dx is 9x squared minus 12x. So how would we find d2y by dx squared?
Oh, sir, can you switch over the screen?
All right, so I'm saying that we have dy by dx is 9x squared minus 12x. How do we find d2y by dx squared now? What's d2y by dx squared?
Do we have to square the x value?
So what did I say is d2y by dx squared?
I remember about it being the minimum and the maximum. So if D2, if the second one, if it's greater than, no, if it's less than, that's the maximum value. If it's greater than, it's the
It's
minimum
minimum, very
value.
good. But how are you gonna find what is d2y by dx squared now? d2y by dx squared does mean you differentiate dy by dx. So it means you differentiate this again. All right, that's what d2y by dx squared means. So when you differentiate 9x squared minus 12x, what do you get?
So we have 3x minus 4.
When you differentiate 9x squared minus 12x, what you get?
Oh, so you have to do it over. Okay.
Yes, you're
9
differentiating the function again.
18x
18x
minus 12.
minus 12, good. So now this is the second derivative. So now let's determine which of these are maximum and minimum points. So d2y by dx squared is 18x minus 12. So what you're going to do is you're going to plug, let's look at this stationary point first at 0, 6. All right, so let's plug in when x is 0 at this point. All right, so the stationary points are 0, 6, we know that. All right, well, let's determine their nature. All right, so what we can say is at 0, 6, is the second derivative negative or positive? At 0, 6, d2y by dx squared is equal to what?
18x is equal to 12.
It's equal to negative what?
No, it wouldn't be negative, it would be 12.
When x is 0, it's going to be positive 12?
Yeah, 18x minus 12 is equal to 0, so 18x is equal to 12.
All right, now at which one of these is your x value? Which one of these?
Oh, you have to plug in the x into,
Yes, you have to
okay.
plug the x into this now. So you're going to
So it'd be
substitute x
negative
as,
12.
yeah. So you're going to get 18 times 0 minus 12, and that works out to be negative, don't it? Don't it?
Yes, sir.
And so what we're saying then is 0, 6 is, 0, 6 is what?
Maximum.
Is a maximum stationary point, is a max stat point. When I write max stat point, I mean maximum stationary point. All right. Now let's investigate at the next point now at 4/3. The point is at 4/3. At 4/3, 22/9. But 4/3, 22/9. What's the station? What's d2y by dx squared?
Twenty-four minus 12. 12.
It's going to be 18 times 4/3, and you get 24 minus 12, and that is what? This is what?
12.
This work out to be 12? That's 12? That's equal to 12. And what do you know? That's what? Greater than 0, don't it?
Yes, sir.
So this is a what kind of stationary point?
Minimum.
Very good. So what we're saying then is that 4/3, 22/9 is a minimum stationary point. Is a minimum stationary point. Very good. Right? And that's how we determine the nature of stationary points. Finally, now we're going to look at application of differentiation. So as you can see here, this is real life application now. So you were asking me where we use this. And as I was saying, we mainly use this in mathematics area. So this is a real life question. I remember when I was doing add math. And this was when add math just started and it had SBAs, and I was doing the add math, and we got my SBA was to use differentiation in order to come up with, I think what they were saying was, imagine the track and field coach wanted to implement a water system in school. But the track and field coach, he doesn't have an idea of what the dimensions of the igloo should be, and you have to take into consideration that the school only has $50,000 to purchase a particular tall container or tank in order to have water for the athletes to drink from. So the school is pretty much going to purchase a water tank, and it shouldn't cost more than $50,000, but they want to maximize in terms of the volume of water that can be stored in the tank. So we had to use differentiation in order to come up with the dimensions of the tank, as well as to ensure that it could give us maximum capacity of water for the athletes. So it was really fun, and that was application of differentiation. It's not really too much in computing, but here's another application where it gives us the total volume V of a water tank of width W meters is given by 36W squared minus 3W cubed. So this is just a volume formula that gives us the total amount of water in the tank. All right, so the volume is measured by width. Let's say given that the width may vary, find the value of W for which the volume is stationary, and determine the stationary value and state whether it is maximum or minimum. So listen what the question says. It says, given that W may vary, find the value of W for which V is stationary. Now, when is V going to be stationary? When is V stationary? When is V stationary? What happens at a
When it's
stationary
zero,
point? When what is zero?
gradient,
Repeat.
gradient,
The gradient. And what will be the gradient of V?
like how you'd write it,
Yeah, how do you write the gradient of V?
EV over
dV.
DW.
Yes, dV by dW. Very good. So we know that it's going to be stationary when dV by dW equals 0. So that's what we're going to do. We're going to find dV by dW. Finding dV by dW, it's going to be equal to, what's dV by dW? What's dV by dW?
72
72, yeah,
W
W, yeah,
minus 9
minus
W squared.
minus 9W squared. Very good. So that's dV by dW, and it's stationary when this equals 0. So we're solving when 72W minus 9W squared equals 0. Now solving this equation, anytime they have a common factor, factor it out. So we're going to factor out, they have a highest common factor of 9W. So I would factor out 9W, and I'm left back with, what am I left back with? 8, because 8 times 9 is 72, so I'm left back with 8 minus W. That makes sense?
Yes, sir.
And so I left back with 8 minus W, and that's equal to 0. So what's W equal to? 9W times 8 minus W equals 0. What is W? So what W equal now?
Um, so would W equal to -8?
W equals 0, because you have 9W equals 0, so W equals 0. Or if you have 8 minus W equals 0, what is W?
-8?
Negative 8. 8 minus negative 8 is 0.
Positive 8.
Positive 8, because 8 minus W is 0, so W is 8. Now look at this now. Now W cannot be 0. Tell me why W cannot be 0.
That's
Why
not the
W?
origin.
No, W
Oh,
cannot be
so
0.
it means,
Then there's no tank.
yeah.
So W can never be 0. If W is 0 meters, then there's W 0, there's no tank, then there's no volume, then this would make no sense. So W is 8 meters. If you want to know 8-meter tank, that's pretty wide. That's a decent sized tank. If you have a tank that's 8 meters wide, that's a good tank. So where I'm from in St. Thomas, like usually there's not running water every day. All right. So sometimes what we do is that we have to buy tanks. Most people tanks is between 3 meters wide. So this tank is very wide. 8 meters, that's a wide tank. All right, so this is a wide tank, 8 meters for the width. That's a very wide tank. So this must be for a company. It wouldn't be for a house. Usually people at home have a tank of like 2 to 3 meters wide. Some people even less, 1 meter wide. All right, so we know that W is 8. So we'll find that W is 8. So first it did ask us, find the value of W for when V is stationary. W is 8. Now the second question says determine and state, it says determine the stationary value. What will be the stationary value?
Minimum.
We don't know if it's minimum yet. No, but before we even look at whether it's minimum or maximum, how are we going to find the stationary value?
We'll plug back 8 into the
Very
equation.
good, very good. Plug back 8 into the formula to get the stationary volume. You get that this is when W is you get that this is when it is stationary. So get the stationary value now by plugging in 8 in this formula. So you plug in 8 to get the stationary value. All right, so let's look at the calculations here. So solution dV by dW, we get W is 8. And V is stationary and dV by dW is 0. So plug in 8 now. When W equal 8, V is equal to 36 times 8 squared minus 3 times 8 cubed, which equal to 768 meter cube. Now that's a lot of water. That's a huge tank. That's a very huge tank to have 768 meter cube of water. And remember, 1000 cm cube is 1 liter. So this has what? How many liters? That's so many liters. That's a lot of water. All right. Now the next part says state whether it is maximum or minimum. How do we find if it's maximum or minimum?
We'll differentiate dv over dw.
Very
So
good. So we differentiate this to get
we get the points. So d d2 v over dw squared.
yes. And what it equal to when you differentiate this?
72 minus 18.
Very good. Very good. So that's d2v by dw squared. Now, when you get that now, what you're gonna do to determine whether it's minimum or maximum?
Try to find the points.
So
So
you're trying to determine if when W is 8, determine whether whether it is maximum or minimum. How do you know if it's a maximum stationary point or a minimum stationary point?
So you equate it to 0.
No, you plug in double as 8
Oh,
now.
8 again.
You plug in 8 now to determine. So you plug in 8 in the second derivative, and you get that it's negative. And so V has a maximum. V has a maximum value when W is 8. All right? V has a maximum value when W is 8. All right?
Yes, sir.
I'm going to stop here for today. So next class now, next week we're going to go through connected rates of change. We're going to look at product rule of composite functions, quotient rule of composite functions, and we're going to look at trig differentiation, exponential and logarithm, and then we'll do a worksheet with all of these, all right?
Yes, sir.
All right, so a lot to remember. I'm going to share with you these differentiation notes now. It's a lot to be studying, I know. I know it is a lot. I know it is a lot. But remember, as long as you do it 3 hours a day, you'll be perfectly fine. All right? All right?
Yes, sir. So,
All
did
right.
you send the binary operations solution?
No, I didn't send the solution as yet. I don't finish marking paper. I fell asleep when I was marking halfway. It was actually a very long assignment, don't it?
Yes.
Yeah, it's very long. I reached
Skip out
halfway.
some questions. So,
I noticed. All right, so I'll be finished marking it pretty soon. Trust me,
yes,
you're
sir.
gonna get it. You're gonna get it very soon. If not tonight,
Um,
tomorrow. All right.
yes, sir.
All right. So now it's been 1 month. Now we have sessions. So I'm gonna send you my banking information. All right.
Yes, sir.
All right. All right. So I'm gonna send you that tonight, as well as I will send you the mark script. If not tonight, tomorrow morning. All right.
Yes, sir.
All right, so let's take care, take it easy, get some good sleep tonight, and then tomorrow, back at it again. Remember, 3 hours a day. All right?
Yes, sir.
All right, so take care and have a good night.
You as well, sir. Bye.
All right.